who are unable to join us today and requested a recording of the meeting, which we'll go ahead and do. So yes, we've gone ahead and started recording. Okay, great. So as I said, I'm Joan Obra, and I'm the Vice President of the United Ka'u Farmers Cooperative. And co-hosting with me today is Lori Asan, who is the Treasurer of UKFC. And also present is John Asan, who is the President of UKFC. So I'll tell you a little bit about our organization. We are a nonprofit research cooperative that is dedicated to furthering the education of coffee farmers throughout the state of Hawaii. And all of our members are based here in Ka'u, and we're working farmers who've collaborated over the years on scientific research with CTAR, PBARC, the late Lansanto at the Hawaii Agricultural Research Center, and of course now the Kohala Center. And this is how we actually met Dr. Melanie Willich. And if you don't know the Kohala Center, it's an independent research, education, and Aina stewardship nonprofit for healthier ecosystems that's based in Waimea here on the Big Island. And Melanie is its director of Aina-based applied agriculture. So Melanie has a PhD in organic plant production and agro-ecosystems research in the tropics and subtropics. And before joining the Kohala Center in 2016, she worked with the DFG Research Training Group in the Sultanate of Oman in Germany on regulation of soil organic matter and nutrient turnover in organic agriculture. Before she joined the Kohala Center, she also used to be a research associate with the College of Agriculture and the Natural Resource Management at UH Hilo. So today's webinar stems from our collaboration with Melanie on a project that's become all the more useful given the advent of coffee leaf rust in Hawaii. In 2019, we received a specialty crop block grant from the HDOA to test out 3 different ground covers that hopefully will address nutrient deficiencies in Ka'u soils that were identified by the late Lansanto at Hark. So we're planting test plots of perennial peanut, cowpea, and stylo across 5 Ka'u fields, all in different locations and microclimates. And over the next year or so, we're going to be taking soil and coffee leaf samples, as well as analyzing the biomass of the ground covers that we plant. And because of CLR and this call to spray the copper-based fungicides, which is the reason why we're all here today with each other, the Kohala Center is also devoting some of its future monies to measuring copper levels in our soils. And hopefully we can determine if the ground covers that we're planting can actually pull some of that copper out of the soil. And Melanie will talk a bit more about this. So before we fully get started, I just wanted to share something with you. So let me pull this up here. So UKFC, we recently started a YouTube channel. And so we're going to be posting additional content here about our cover crops project. And this is the only thing we have up there that's publicly posted at this point. But once Melanie gets started, I'll go ahead and drop that link into the chat so you guys can see it. Without further ado, we'll go ahead and turn it over to Melanie, and we'll hold a question and answer session until the end. But feel free to type your questions in the chat as we go along if you like, because at the end, I'll go ahead and read those to her so she can answer them. Also at the end, we'll ask you guys, if you want to ask her your questions directly, just go ahead and unmute yourselves. But for the moment, if you all could stay on mute, that would be great. And I will stop screen sharing here so that Melanie can go ahead and start. Let's see. Melanie, are you able to start?
I hope so. Thank you, Joan, and thank you so much for having me here today. I hope my accent isn't too strong to follow. I also took many notes to hopefully help that we get through all this content, so and have enough time for Q&A in the end. I'm also happy to stay on longer if that's necessary. Okay, let's share the screen. Is everyone able to see this?
Yep, it comes up just fine on my end. Hopefully it does for everybody else.
Yeah, okay, let's get started here then. Yeah, as Joan said, this really developed quickly from our project looking at soil health into the growing concerns by the growers with that new disease, the coffee leaf rust being on the island now and having to be dealt with. And at this point in time, copper-based fungicides being the only spraying control agent that is permitted and is also very effective for a range of foliar diseases that is being applied worldwide by fruit, vegetable, and field crop growers. But with that, there is also a concern since copper is highly effective when it is applied before onset or very early in the onset of the disease, that this requires frequent and repetitive application, which can potentially by rain be washed off the leaves into the soil. So the concern is, of course, what does elevated copper levels do in the soil to the soil microbiome, and to which extent the crops take up these excess levels of copper, and how does that potentially affect crop health and growth and yield. So this is a very good time to be together here today and talk about soil health, review what does that mean and what are the influencing factors, as well as how does soil health relate to crop production, like why do we even care about that? And then I was reviewing some literature of what does the data show on basically using copper-based fungicides for the last 13 decades, and what is known about the effects on especially the soil biota. And we will then go into what can be management practices for going ahead and using these fungicides as our only available option in terms of spraying at this point from a soil health perspective. Okay, so without further ado, let's get into this. So what is soil health and what influences it? Soil health is defined as the continuous ability of a soil to provide functions that sustain plants, animals, and humans. And those are a range of functions that include regulating water, as in infiltration into the soil, and also filtering, groundwater recharge, so very important in the water cycle. But also all biomass, plant and animal life is anchored in the soil. So our entire food production obviously depends on that natural resource base, as well as the soil is giving the physical support as a place for the roots to anchor. It is also through the microorganisms fulfilling filtering and buffering functions and neutralizing functions of pollutants such as heavy metals and pesticides. It is absolutely crucial in the cycling of carbon and other biochemical nutrients cycles, including nitrogen, phosphorus, and sulfur. And it is also this habitat for biodiversity, as if you imagine on a heaped tablespoon of soil, there are slightly more microorganisms than humans on the planet. And that goes to show that the talk about soil health is something that only living things have health. So that is a fundamental shift in how we view soils as compared to the last century, where that was mainly limited to soil chemistry and looking at it more as an inert medium, whereas that is really shifting into considering these very important roles that soil biology play. Yeah. Now, there are a number of soil properties that are related to the proper functioning of the soil, and the ability of the soil to fulfill these functions depend on the state of these soil properties that can be distinguished in physical properties, chemical properties, and biological properties. Now, the very central soil property that influences soil functions is soil organic matter. And soil organic matter includes all the organic substances in the soil, as you can see in this pie chart there to the left, how the composition is of soil organic matter in general. It includes living organisms, also fresh residue like roots, and then different fractions of soil organic matter, the more stabilized humus, and also the more reactive, easily decomposable fraction. Overall, it makes only for a small fraction in the topsoil, but it is absolutely essential for the physical, chemical, and biological functions of soil. Now, why is it important? Because soil organic matter affects all of these parameters. Yeah, soil organic matter increases aggregate stability. It also decreases bulk density, makes soil lighter, and thereby it can increase the infiltration of water, and also can act better as a sponge. If you look back into the physical parameters such as soil structure, like the composition of sand, silt, and clay. That is something that we can affect very little, because either we have a sandy soil or we have a clay soil. But with increases of soil organic matter, clay soils can become lighter and get improved tilth, while sandy soils can be getting better water holding capacities with the additions of soil organic matter as compared to sandy soil itself that would easily leach water through and not be able to retain that so well. So chemical soil parameters that are affected by soil organic matter additions are nutrient availability and supply, nutrient retention, the CEC stands for cation exchange capacity, which is in terms of soil minerals, the highest in clay, the lowest in sand, and that has to do with the quantity of negative surface charges that cation or basic iron nutrients can be attached to and more retained in the soil in exchange with the roots for plant nutrition. That also is these negative surface charges is also something that soil organic matter particles bring into a soil, so that in a sandy soil, nutrient retention can be much increased and improved by the addition of soil organic matter. It also buffers against pH changes, and that we will look at later, how that is playing such a tremendous role in the nutrient availability. Biological soil parameters, soil organic matter increases microbial diversity. There we are at the root of what we want to talk about today, as a diverse microbial community not only ensures nutrient cycling, setting the plant up for greater resilience in terms of plant nutrition, but also microbial diversity helps to suppress pathogens. Now, soil organic matter itself is heavily affected by management practices, which in turn influence soil physical, biological, and the chemical functions. For example, if we look here at tillage, tillage increases the oxygen in the soil, so that is stimulating microbial activity that results in a quicker decomposition of organic matter. And then if additions of organic matter are not sufficient to counteract these losses of an increased decomposition from the microbial activity, then these levels of soil organic matter will decline over time, resulting in a decrease of soil health and soil fertility. So to summarize this up, we'll briefly, what are the characteristics of a healthy soil? Sufficient but not excessive supply of nutrients. If you think of these microbes in a highly dynamic ecosystem that keep that running smoothly, that is generally the result of it. A good structure and aggregation, which is related to greater resistance to erosion, compaction. We talked about that. What soil organic matter in particular helps with reducing bulk density, but also stabilizing soils that might be more sandy, that easier are prone to erosion or nutrient losses, and also a better bouncing back ability from episodes of degradation, and greater resistance to pests or pathogens and certain environmental stressors like drought. It's characterized by low populations of weeds, plant pathogens, and parasitic organisms. And again, why is that? Because a healthy soil is harboring a diverse population of beneficial organisms that enhance plant nutrition and are able to suppress pests. Now, going a little deeper into why and how, again, does soil health benefit crop production? For that, let's take a look at what's known as the soil food web. Yeah, microbes mediate about 90% of soil functions, including decomposition, respiring carbon dioxide, making nutrients available, and storing carbon. And if we look at this left side, it starts with the plants themselves, converting carbon dioxide into organic matter, and then the plants and residues become food for the decomposers or second trophic level bacteria and fungi that then have predators in the third trophic level and so on and so on. So just talking about these different organisms and their functions, we briefly, the bacteria, they are the organisms that decompose these very easily available residues, basically highly available organic matter like sugars, amino acids, proteins, fatty acids, and root exudates. There are also harmful plant pathogens, but also in the actinobacteria, again, antagonists for these harmful or plant attacking bacteria. Fungi are also very important, or what I want to say about the bacteria is that in agriculture we get a lot of the benefits such as the nitrifying bacteria that basically convert these organic materials into the inorganic available forms of nutrients that the plants can take up. Also, the nitrogen fixing bacteria are in that level, trophic level. The fungi also very important that decompose more woody materials that bacteria cannot get to, but also in that group are the mycorrhizal fungi that build symbiosis with plant roots to help making nutrients, in particular phosphorus, more available. And then there are also the nematodes, of which we know pathogenic nematodes that attack our crops, but then some of them feed directly on roots, but then it is a very complex group that also includes nematodes that feed on these plant pathogenic nematodes. And then, it goes on and on. The protozoa, they live in the rhizosphere, so in the area around the roots. They play a very important role in making nutrients available to the plants, again, because they are feeding on the bacteria, and the nutrients contained in them then become available to the plants. Then the arthropods are basically shredding organic materials into smaller pieces, making that more available for these microbial bacterial turnover of nutrients. benefiting plant nutrition. And some of them are shredders, others directly feed on fungi and bacteria. And then, of course, we have the earthworms, these ecosystem engineers that build channels and also which improves water infiltration. That is something that we need for the nutrients to actually diffuse to the roots. Very, very important. And also for soil aeration, they play a very important role. And they also ingest mineral soil particles as well as organic matter and mix that with their micro gut biome and excrete then what's known as worm cast, which is really improving aggregation in a soil. So you see, this is a very complex dynamic web as it exists in a healthy soil and regulates a lot of nutrient turnovers, but also a pathogen control. Again, as all these organisms, of course, breathe, let's look at this little picture here as basically what makes up a carbon balance or carbon fluxes in an agricultural ecosystem. There are the inputs through photosynthesis, and then there are losses through soil respiration, indicator of activity from decomposing microorganisms. And then there is also storage into the more stable fractions, the humus. And if these inputs exceed the respiration, then we have what's known a net sequestration. So now in terms of climate change, this has become a really big focus because the soil is the pool in which more carbon is stored than in all animal and plant biomass and the atmosphere combined. And you need to imagine that the majority, over 95% of carbon dioxide in the atmosphere is microbially respired carbon dioxide. So the way we produce food very much affects this balance. But coming to why are we talking about it in the context of this presentation is certainly because it gives us, soil respiration gives us a measure of how, of soil health in how active of soil biology do we have, because that gives us then an indicator of decomposition levels of soil organic matter. And that in turn gives us an idea of the soil's ability to sustain plant growth. And that is a really easy field test that I think we were planning to play this video.
Did you want to play this video now, or did you want to play it after the presentation, Melanie?
Let's play it later.
Okay, I've got it queued up whenever you're ready.
Yeah, let's play that later. Okay. That is just a field test that I do, and we will watch this video about it. That's just like 3 minutes long. And from the results then, there is an interpretation guide of, okay, so what does that indicate now in terms of my soil's health? And in general, agricultural practices that increase soil organic matter will have a higher carbon dioxide respiration, but then it depends on context. If that goes into this excessive range there of respiration, that could be caused by something like tillage, what we discussed earlier, while maybe that's not so relevant in coffee cropping systems, but more so looking into the other end of the range, especially when we're applying more fungicides or pesticides into, you know, what does that indicate when we have low levels of carbon dioxide respiration, then there might be only little soil organic matter that's being decomposed, little microbial activity. And with that, that can give us an indicator of, okay, there is not so much nutrient turnover happening then, what to be expected. And also this intrinsic web of pathogen attacking microbes might be disrupted or not fully functional. And yeah, that is where the value of this test lays. Now, going a little more into this, what role does soil health play in crop defense? Yeah, the rhizosphere. What's the rhizosphere? That's basically the area around the roots that you can imagine as an ecological niche in which the beneficial bacteria compete with other microbiota for low molecular weight organic compounds that basically leak out of intact roots. And that is also called a root exudate. Now, the language of nature is chemistry. And these root exudates, it's a highly complex environment there in the rhizosphere. And these root exudates, they are affected by the microbiome. And in turn, the microbiome is affecting what root exudates the plant releases. So really, not only are those root exudates that are organic carbon compounds, so there are sugars, there are amino acids, fatty acids. So it's a busy zone there in the rhizosphere, and they are very much acting as messengers between the roots and those rhizobacteria, yeah, the microorganisms that live right in that zone. And these interactions, they facilitate then different responses, yeah, so including plant growth promotion. For example, how specific exudates attract the rhizobia, these nitrogen-fixing bacteria, into the vicinity of the roots, so that they enter symbiosis and help making atmospheric nitrogen available to the plant root. Or there are certain enzymes that plant that is recognizing phosphorus deficiency is then exuding through the roots that can either mobilize phosphorus out of organic materials, but there are also mechanisms with organic acids that the plant root can exude to solubilize phosphorus from mineral surfaces. And with all that, the plant can actively support getting nourished better, but also it can, through the root exudates, induce defenses against plant pathogens through a variety of mechanisms. And in a diverse microbial, healthy community, very much of that is simply through outcrowding, competition of, like bluntly speaking, the good guys versus the bad guys, and the more intact soil microbiome is, the better these mechanisms work, including this outcrowding, competition, parasitism, and other mechanisms. So all that now as a background, let's go into the specific literature on residual soil effects of copper-based fungicides. So I found a few articles. Vandermeer here, this first one, the current recommendations, and that is throughout the literature, are focused on fungicides and phytosanitation procedures based on uncertain background information. So maybe better terms, instead of based on uncertain background information, is regardless or not considering of background information, as he argues, and John Vandermeer is really one of the worldwide leading ecologists. And what he's arguing is that the current coffee leaf rust management does not sufficiently take into account the relationship between production situations and the epidemiological process. It's been shown that more complex traditional forms of coffee cropping systems have previously acted as a buffer against the severity or incidence of the coffee leaf rust. So there is a call and a need for developing more nuanced management systems which integrate crop management practices in order to manage this disease in a more sustainable way. Especially studies on annual crops have shown that the crop management component is key to managing the disease in an integrated way. That paper there by Avellino explains why crop management influences coffee epidemics and how that knowledge can be integrated into rational disease management systems. Also, there are studies available that show that that fungus may mutate and develop fungicide resistance. Also, what became clear through this literature review is that changes in the microclimate, like wind, rainfall, light, temperature, and the host plant physiology, like leaf area, leaf wetness, and fruit load, influence the different components of the coffee leaf rust infection cycle. The advantages of using copper-based fungicides clearly are the high toxicity that is very efficient if applied early to the plant pathogens, relatively low cost, low toxicity to other mammals, and a prolonged residual effect, given that it's not applied before a rain event where it gets washed off, right? Disadvantage are phytotoxicity. If it exceeds a level to which the plants react with toxicity syndromes, like in this citrus orchard there, the photo shows a typical sign of uptake of too much copper from the soil into the plant, which then leads to these spots that reduce the quality and marketability of the fruit. Also, the development of copper-resistant strains, the mutation of the fungus that has to do with co-evolution and is reported multiple times over and over again. Soil accumulation, another concern. We will talk about this in another slide now. And the negative effects on the soil biota, which, as we just talked about, plays such a crucial role in soil health and functioning. Also, internationally, there is increasing regulatory pressure. Use becomes more restricted, which also drives that need to come up with mitigation strategies that use it in a more optimized way, but also as part of a greater management strategy.
Melanie, I just wanted to let you know it's 3:15 since you'd asked me to give you the heads up at that time.
Perfect. Okay, we're doing pretty good. Thanks. Here, just a quick overview. If we think of an uncontaminated soil having copper contents of less than 20 milligram per kilogram, you can see that there are high residues across major cropping systems worldwide, particularly perennial crops that easily have 40 to 50 times more copper than uncontaminated soils. But however, so the potential toxicity of copper also is from soil to soil, independently of the copper concentration accumulated. Let's talk about that. So this slide shows basically the major influencing factors on what to expect copper to behave like in a soil. That is texture and that is pH. So first of all, we talked just so briefly about the cation exchange capacity. And you probably heard already that copper levels are higher in soils that have more soil organic matter or clay content. Why is that? Because as we said before, these particles have negative surface charges, as you see here in this right part of the picture, that copper can bind to. Yeah, copper exists or appears in the soil as a cation, 2+, copper 2+. And so it binds to these negative surface charges. That is taking the toxicity out of the soil solution, because you can imagine this now as a sponge, in that it is there, but it is not available. That is a little similar to the arsenic situation, yeah, where levels can be very high, but not cause toxicity because it's bound to the surfaces of either clay particles or soil organic matter. However, there is also a relationship to the pH, and that is that as the pH level decreases, which technically means there are more hydrogen ions in the soil solution, that also displace the cations from these negative surface charges, then basically leaching the copper into the soil solution, and then two things can happen. Either they get leached out into the groundwater, or taken up by the plant and having potentially toxic effects. And of course, the more copper there is in the soil solution, the microbiome reacts very sensitively to that, as microorganisms tend to be more sensitive to heavy metals than other organisms. Now, with coffee and our inherent soils, we are really in this critical zone, because coffee is a plant that does like it slightly acid, and in that pH range also we have our micronutrients available. Yeah, I think that copper is also a necessary micronutrient for the plant. That's why the, copper fungicides have this reported tonic effect that actually helps with yield. But it all has to do with balance and amounts. Yeah. And we get to the micronutrients in a second. Here, I just wanted to show what does the data show on the effects of copper fungicides on soil biota. And block 1 and block 2 here is referring to an avocado orchard that was sprayed, and then there is a reference control that was not sprayed. And you see, microbial biomass is measured as microbial biomass carbon, which is, if we're only looking into this topsoil layer there, lower in the sprayed soils compared to the control. And if you look at the soil respiration, metabolic quotient, you see that in the sprayed soils, both of these measures are higher than in the reference soil, which in this case is indicating that the microbes were stressed. Here, this is about the earthworms, where they have done avoidance studies. Basically, they let them choose between a contaminated soil versus a controlled soil, and also did different dilutions and see where do the worms go to. And they started avoiding soils when copper levels reached between 4 and 34 milligram per kilogram. And you see when it hit here beyond 400, there are 500 something milligram per kilogram, like over 90%, 95% there of the worms were absent. And again, these are our ecosystem engineers. that play very important roles. Now, how can we deal with this? Because the disease is here, it needs to be dealt with. But how do we keep our resource base intact? So any factor that can reduce any of the infection stages, even a small amount, can mitigate the epidemic. That is clear from the data. And we have it here more complicated with being a tropical environment and a perennial crop compared to temperate climates where we have a winter break in pest development or annual crops, or where we do have these very effective disease cycle breaking tools like crop rotation. So we cannot do that. But what do we have? We have field sanitation practice for monitoring, for very early being able to hit with a copper spray, but also all these associated practices like pruning, irrigation, and then in particular fertilizer management and the soil pH, because that affects the availability of the nutrients. And in that, the research around the coffee leaf rust has shown that susceptibility is generally reduced with proper nitrogen fertilization and phosphorus fertilization. It is increased when there is an excess of potassium. Yeah, so not only amount but also balance of the nutrients play a role here. And it's the severity is generally reduced with micronutrient applications. That is something that is so often overlooked, I think, although the micronutrients play such a crucial role in setting the plant up to withstand biotic and abiotic stresses. And I wanted to show here this Liebig's law of the minimum. When you think of the water there in this barrel as the yield, it is determined by the most limiting nutrient. That is what the Liebig's law of the minimum says, and that's at the very foundation of plant nutrition. Yeah. So doesn't matter how much nitrogen you apply when you forget about a micronutrient. And that is something with which we can really support the trees. Here are just the levels of, what are we talking about in terms of copper, and you see that range is pretty narrow there, with beyond 20 milligram per kilogram starting to cause toxicity effects when it's less than about 6 to 10 milligram per kilogram of copper. We start to see deficiency syndromes. So sampling, it is the most powerful tool that you have available, and we don't have the time to go in detail here, but there are publications by CETA, and that way, especially when you start spraying now, maybe aside from considering to measure the carbon dioxide respiration, this as a biological indicator, this here is your classic chemical indicator for knowing how are your nutrient levels in the soil and in your plant tissue affected by your management practices? And closing this now, again, how do you maintain and improve soil health to support your crop health? What do we have available in a coffee system? Yeah, minimize soil disturbance. That's not so much happening there. Yeah, in like I think only a few growers here might really till in between the rows. But yeah, how do we increase the microbial diversity? Yeah, and keeping the soil covered as much as possible. What are our tools here? We don't have crop rotation, but we certainly have cover crop options. Coming back to this project that we're working on with the KU growers right now. Yeah. Maybe to look at the traditional knowledge is a very relevant aspect here because plant epidemics are driven by the plant growth and the pathogen development in interaction with their environment and cropping practices. And this view of taking care of the land that in turn takes care of you is very much along this system perspective of moving forward.
Melanie, did you want me to play that video now?
Sure.
Okay. So we're about to, I'll share my screen here, and this is a video about the Solvita test kits. Melanie, do you want to introduce this a little bit to, I think farmers probably need a bit more about what is the purpose of this kit. So once you get the numbers, what do you actually do with that information? Oh,
I'm here on mute, I guess.
That's okay. I just unmuted you. So
the nice thing about this, first of all, this is really an affordable test, and it is a tool that you can use directly in the field, because usually you would measure carbon dioxide with, laboratory equipment. And it is remarkably precise, and it just gives you this indication of, do you have an active microbial community there? You get, and they calibrated that. It is this color strip. You incubate the soil sample in it over 24 hours, and then it is changing into a color that is according to the daily respiration rate of carbon dioxide per acre. And from that, it also comes with, okay, so what does that mean now?
Mm-hmm. And so if you could explain a little bit how that relates to once people start spraying copper soils and we start to see an increase in copper in the soils, how would that be represented in this test?
In that, I think along with doing regular soil nutrient analysis, you can relate that and see, well, do you have a decrease in microbial activity over time? So it's like one test is one point in time that gives you only a limited amount of information. This is something that should be second nature at least once a year to do that, to start seeing a record of what is the situation, like especially now, but we're starting to spray copper more, but also in general, for your plant nutrition protocol, your fertilizing protocol, basically.
Mm-hmm. Yeah. And I'm looking at the time here. I know that we were thinking that we were going to play this. It is already 3:33, and I want to make sure that we have enough time for farmers' questions. So why don't we start there first, so we can make sure that we address all of those. If there's anyone who has any questions at this time, please feel free to unmute yourself and turn on your video so that we can see you, and go ahead and ask your question. Okay, and just so you know, I do see Carolyn, if you're here, Carolyn Whitcup, I see your question here. She asks, how quickly does this fungus become resistant?
That is something that unfortunately I cannot, give a conclusive answer. I think that is something to ask a plant pathologist about. What is known is, can we, like, first, that is, requiring a research that hasn't been done here yet, but what has been done in comparable climates, because this fungus in particular is present in all major coffee growing regions. So I can imagine that there is maybe more concrete data available, but then again, there are all these different influencing factors in soil type and climate, the amount of spray, the extent to which that accumulates, and I think that would be really a question for a pathologist.
So as a practical matter, Melanie, how often would you say people should be taking their soil and tissue samples and doing a field test like the Solvita test kit?
I'd say at least annually. Yeah, and I think the extension service is also working closely with the coffee farmers on that. So in that perspective, there should be a lot of data available.
Mm-hmm. Are there any other questions from you guys before I play this video?
Yes, this is Steve Braun. I have a question.
Hi, Steve. Thank you so much.
So I have a coffee field, 7 acres, and I've been spraying Botanigard and mixing Kocide and double nickel with it. And I've done that 3 times since July. And I saw the ad for this meeting. There's a danger to putting too much copper, which is the base of Kocide, in my soils because it's going to get back up in the tree. So 3 times since July, I've done that. The trees look pretty good. And I've used the double nickel and Kocide to fight Anthracnose and Cercospora, which has been successful. Now I'm wondering, is that too much, or I was just going to spray my farm again with those 3 ingredients, and I was curious if that's not overdoing it.
Okay. I mean, the most important thing is to prevent the spread by all means of the disease. And in terms of, interactions there with the Botanigard, like all I saw is the publication that the Extension Service just came out with that includes all the different copper sprays that are permitted at this time. And I think there were some indications of, whether this can be used with Botanic Garden and what's the efficacy or not. So I'm not too deep in that, but yeah, as that publication says, that the label is the law. I think there were recommendations about the amount that can be sprayed, and that I think, yeah, is important to adhere to, as to not, spray too extensively and kill the plants with that.
Did that answer your question, Stephen?
Yeah, I guess I'm not sure how often I can put Kocide on the trees. I guess that's boiling it down to that question. For danger of getting in the soil and then being toxic back up into the plant.
I think that's a great question, and I'm not sure who might have the answer, but I too wonder about application rates, frequency, if we're rotating with other types of chemicals, the impact on that. I'm not sure. Does anybody know? I mean, does Andrea maybe have that kind of information, or?
Yeah, I would sure hope so. There are lots of studies that are looking into or looked into where, what's more effective, rotating between different sprays versus mixing and spraying at the same time. So that is something that I would have to follow up with, as I come really from this soil background. I'm not a plant pathologist, and this technical, very important information. Yeah, I would imagine that Extension Service gives out some guidelines on that.
Great, thank you. I'll follow up. Thank you.
Thank you.
There we go. If there aren't other questions at this time, I'll go ahead and play this little video for the Solvita test kits, and you folks can think of more questions as this is going. This is only about 3 minutes and 30 seconds.
I'm not sure if I'm the only one not hearing the tone, but basically what they're doing is taking a sample, and then you see they're weighing it in, and then they're incubating it with this test strip over 24 hours, and then it is changing the color according to the microbial activity. And then you can compare that to this color chart, and that is indicating the respiration in pounds per acre per day. Yeah, and here they are talking about these extremes, and as we had this one slide with the interpretation chart. And I think we can make the slides available to everyone, right?
Yes, we can make the slides available. And I see a few of you have messaged me about how there's no audio. So what I'll do is when we send out the link to the recording, we'll also send out the link to this video so you folks can watch it. Sorry about that. We tested this out yesterday and it was working, so I'm not sure why it's not now. Okay. There we go. Do you folks have any other questions? Because I also have a, oh, sorry, go ahead.
This is Linda Murphy. I have a question for you. Can we buy the Solvita test here in Hawaii? Because it costs about $85 to get it shipped here.
Melanie, do you have an answer to that? I know that Kohala Center's been looking into that as well.
Yeah, so I think, so we're working with a few farmers on this, and also our state's soil scientist, Amy Koch with the USDA, she's also using these. So I think if there were multiple people interested in this, we could order that through the Kohala Center and then distribute. So, you know, that you would not have the additional cost of the shipping.
Through the Kohala Center. And is there a phone number for that? How can I reach them?
Yeah, Linda, I think, did I put my email address on the cover slide?
I'm not sure if you did, but Melanie, you can also drop your contact info into the chat. And we can include it. Also, yeah, and we can also include it in the email when we send the recording out to folks.
Yeah, please know if you're interested in this or if you have any other questions.
Yeah. So Melanie,
and,
oh, sorry, go ahead.
And are you going to send us, I'm assuming you're sending us all these documents?
We'll go ahead and send you the slides as well as the link to the video itself, the recording of today.
Thank you.
Sure. And we have a couple other questions in the chat here asking how much does the kit cost and how many tests can the kit support? Do you know off the top of your head, Melanie?
No, I think I would have to look this up. I feel like there is a 6-pack.
I think I saw that on their website.
Coming as a 6-pack, and I think that's about like what, between $40 and $60, something like that. In that ballpark, at least. It's not too off. yeah, these the jars with the lids, you can reuse those, and then you would only buy these sealed color. How do you call it? These little, plastic things with the
Oh,
colors.
the test strips themselves.
Yeah, those cannot be reused because they need to be calibrated to 0 as a starting point, and then they go into their sealed package. And so you would have to order those, but they come, I think, in like 20 packs or something, and that's
Okay. So David just dropped in the link for the Solvita product into the chat. Thank you, David. So folks can go ahead and take a look at that.
yeah, nice. Thanks, David.
I also do have a poll that I'd like you folks to take, but just wanted to do a last call for questions for Melanie about any of the topics that we've discussed today.
The links to all the papers that were mentioned in the presentation, they are open access research
Great.
publications. So
Awesome.
when you get the presentation slides, then you can read up on those. And if you have any additional questions, please send me an email.
Mhm. Okay, and I'll go ahead and I'll share a little poll here. As I mentioned earlier, the Kohala Center really wants to help us as we're facing this pest. And so we consider this initial webinar as kind of the beginning of a conversation. So obviously, the more questions that you have, please feel free to contact Melanie. It does seem like there will be some funding to do perhaps another presentations, a follow-up presentation in 2021, Melanie, if I'm correct?
That's correct. And
okay, great.
We also have some budgets for working with coffee farmers on the soil nutrient testing, because that data is really limited here in the state. And yeah.
Mm-hmm. Yeah, and as I'd mentioned earlier, since we're working on a ground cover project with Melanie, we're doing actual soil and tissue testing about quarterly on the 5 fields that we're working on in Ka'u. And of course, we will make that information publicly available to folks as well. We want to help you as much as we can.
Yeah, one very interesting question there is going to be how much of copper these cover crops can also take out of the soil. There are a few papers available that looked into that, not in coffee, but other cropping systems, to see if, in addition to the soil health benefits that we're hoping to see from integrating these cover crops, which are stylo, cowpea, and perennial peanut, into the coffee cropping system, to see if that might also have an effect on this whole copper text there.
Right. Okay, so I'll go ahead and put up this poll here, and just so you folks know, all the answers are anonymous. So it really is to make sure that we're helping to deliver information that's really useful to you guys. It helps Melanie focus her future presentations as well. So there's 3 questions to this poll, and you can choose multiple answers. So they should be pretty self-explanatory. If you have any questions about them, you can go ahead and ask in the chat or unmute yourself and ask here. But basically the first one, we want to know if you had a greater understanding of factors affecting plant health. There's 3 answers that you can choose from there. And number 2 is, did this presentation give you a greater understanding of practices affecting soil health? And so that will help you choose more than one answer. And then the third one is, will you adopt practices to increase soil health on your coffee farms, you've got 3 answers there. Some people saying, I've already adopted soil health practices. Did you learn anything new from this presentation that will help you adopt more of them? And we'll, and I'll go ahead and let that run because I see some people are voting. It does take a while to read through the questions.
Yeah, thank you so much for filling out this evaluation. That's incredibly helpful for future presentations. So please be honest. It's always the best learning effect for us as well to know how we can improve.
Yeah. And while you folks are filling this out, I also just wanted to give a big thank you to KCFA, also the Hawaii Coffee Association. You know, both of those organizations gave us recommendation letters along with PBARC to do our ground cover testing here in Ka'u. And of course, at the time when we applied, we didn't realize that coffee leaf rust was already here, or at least on the way. So it just, we're grateful that we had that in place and that the Kohala Center is committing some extra funding to be able to track copper in soils. And let's all keep our fingers crossed that we can find at least one ground cover that will help pull excess copper out of the soils. Oh, good, Sammy. Thank you so much. Thank you for your comment in the chat. Really glad that you learned a lot. Okay, I'll just let this run a little bit longer, and then I can end the poll and show you guys how everybody voted.
I remember, Sammy. We took samples on that farm already.
Okay, so I'll go ahead and end this poll and share the results. So you folks should be able to see that on your screen. Melanie, do you have any questions based on the results of this poll? Any additional questions for folks?
Oh, can we save this, please?
Yeah, it's going to be on the actual recording itself, and I'm sure it will be saved in Zoom on the back end. This is the first time I've run a poll on a Zoom meeting, so I'm not sure how it's saved at the end, but I know that since we're recording this meeting, we should be able to see it. Okay. Well, I think that wraps up our presentation. Last call for questions. And Melanie, is there anything else that you'd like to add? We're really grateful that Kohala Center is supporting us and that you've dedicated your time to us today. This has been really helpful.
Well, thank you so much again for having me. And as I said, I'm available per email, and I wish you all a happy holiday season and that we work more together next year.
Thank you all so much. I'm going to end the meeting now. Take care. Happy holidays. Merry Christmas, everyone. Bye-bye.